Hello students, today we're going to look at section 4-5 about scatter plots and lines of fit. And the first part of this is going to be a big review from last year, but I want to make sure you still have it solid. And then the second part is going to be something that you're familiar with but you've never used in this context. So scatter plots and lines of best fit. A scatter plot is a graph in which two sets of data are plotted as ordered pairs in a coordinate plane. So we're going to fill in scatter plot here. And you may see it written as bivariate data. And I'm going to write that over here, bivariate data. And bivariate, the prefix bi meaning two, would mean two sets of data, which would be the x and the y. So if we look at a scatter plot, if y increases as x increases, then there is a positive correlation between x and y. But if y decreases as x increases, then there is a negative correlation between x and y. And you might see the word association instead of correlation. Typically it's the word correlation. Now if x and y are not related at all and they're just a scatter and you can't really tell, then there is no correlation whatsoever. And the positive and the negative really represent the slope of the line that you could draw. So if we look at this Carmen's earnings and savings, we have some information about how much she earned and how much she saved. And you can see that most of the points are rising. As x rises, their y rises. So that would be a positive correlation. And because it's a positive correlation, we need to describe its meaning. And so this is as the dollars earned increased, the amount she saved increased. So describing the meaning is just using what the x value represents and what the y value represents, and saying as the x value increases, the y value does something, either increases or decreases. So that would be how we would describe the meaning. So we're going to look down at a couple examples as I fold the paper here. And we're going to do exactly the same thing. We're going to see what happens. I'm going to do one, and then I'm going to let you do the other 3 for practice problems. So I'm going to look at the first one because it looks almost like there's a curve involved in there, but we don't look at individuals. We look at the entire set of data, and it looks like as the x is increasing, the y value is decreasing. So we would call this a negative correlation, and the meaning would be as years increased, hours decreased. So it's just as simple as that, and writing the meaning after we understand what the correlation is. So in part of your practice problems will be to figure out what type of correlation you find in each of these graphs, and then tell me what its meaning is, similar to what I just did here. Now to extend this just a little bit and looking at the scatter plot and figuring out the correlation, whether it's positive or negative, we can also draw what's called a line of best fit. And I know you did this last year, but we're going to extend that just a little bit. We draw a line of best fit, and the kind of rule of thumb with line of best fit is the line should be drawn so that about half the points are below the line and half the points are above. And it's about, so it's not always going to be exact. And sometimes the line will go through some points and sometimes they won't. So we have a situation here where we're talking about years and the number of students per computer. And so we have our scatter plot, and they plotted the data and they put it here, and they used a computer or a calculator to draw the line of best fit, which we're going to look at tomorrow. But and we have a line of best fit, and so we did the scatter plot and we need to determine what relation exists. Well, if you look at all the points, it appears to be a negative relationship, because as the years increase, the number of students per computer decreases. So we know that's negative. And then we drew a line of best fit, and that's on the graph. And so the next part is to write the slope-intercept form of an equation for the line of best fit. So now I have to use this line and figure out some points that are on that line, and then come up with the equation of the line and point slope form, slope-intercept form. So that's what we have to do. So first I need to identify 2 points, because I got to figure out what the slope is. Well, there's one point and there's another point that looks like it goes through the line. So 1998 has 18. So I'm going to use the point 1998, 18, because that is one of the points, and I looked over here in the graph to figure out what it was. And then the other one is 2006. In 2006 there were 5.4. So 2006, 5.4 would be the x and the y. So I need to find the slope of the line. So I'm going to use the slope formula, y2 minus y1 over x2 minus x1. So I'm going to start with m equals 18 minus 5.4 over 2006 minus 1998. And I'm not ashamed to say this, but I am going to use a calculator to do this, because that's exactly what I expect you to do. So we're going to plug these numbers in, and I'll let you see me do that. So we do 18 minus 5.4, and I got 12.6. And I bet you've already figured out that those numbers are wrong. It should be 1998 minus 2006, because that's x1 or x2. You know what I did. I just put the numbers backwards. So 1998 minus 2006, 1998 minus 2006, and that would be negative 8. And so it does give us a negative slope, which was what we decided. And so I'm just going to divide both of those by 2. And no, I'm not. I'm going to just do 12.6 divided by 8. And that gives me 1.575. So negative 1.575 is the slope of the line. So now I have to figure out what the y-intercept is. Anybody remember how to do that? Okay, good. We can't guess because it does not cross, so we're not going to use the guessing. We're going to use an equation of a line. So we're going to do y equals mx plus b, and we're going to plug in the y, the m, and the x and find the b. So I'm going to use this first point because it doesn't have a decimal. So the y is 18 equals the slope, which is negative 1.575, times the x, which is 1998, plus b. So now I need to type in negative 1.575 times 1998, and I got negative 3146.85 plus b. And so I add 3146.85 to 18. So 18 plus 3146.85, and I get 3164.85. So 3164.85 equals b. So now my equation will be y equals negative 1.575 x plus 3164.85, because that's my y-intercept. And so now I have the equation of that line of best fit in slope-intercept form. So for your practice problems, again, you're going to do the 3 others on the other side of the page first, just defining what type of correlation you see, and then explaining what that means. And then this problem I want you to do, you're going to draw your scatter plot. Here's the table. plot those plots on the graph, draw a line of fit for the data. Again, draw the line. It's got to be a straight line where about half the points are on one side and half the points are on the other side of the line. You all may draw different lines, and that's okay. When we're doing it by hand, it's always it's not an exact science. And then we're going to write the slope-intercept form of the equation for the line of fit. So when you draw your line, you're going to have to pick 2 points that are on that line, and then calculate what the equation of that line is in y equals mx plus b form. Take a picture of both sides of the notes page and submit that as your practice problems before class tomorrow.